In this class today, we learned about a few things here that were theorems and postulates. This theorem right here called the converse to the corresponding angles postulate. Remember yesterday we learned in the corresponding angles postulate, if you knew two lines were parallel, then you could say that their corresponding angles would be congruent. Well, now we're doing the converse. If you know two corresponding angles are congruent, then you can prove that the two lines are parallel. We also learned about the following theorem, in which you have the same type of idea with three other of the theorems we did yesterday. So the converse of the alternate interior angles theorem, which states that if you have two lines that are cut by a transversal so that the alternate interior angles are congruent. So in other words, if your alternate interior angles are congruent, then your two lines are parallel. Likewise, if your alternate exterior angles are congruent, then your two lines are parallel. And finally, if your pair of same side interior angles are supplementary, then that means the two lines are parallel. So in each of these, you had to prove that the lines were parallel. Let's look at two examples. Example 1. Look at this one here. We have that we're given 4 and 8 are congruent. So let's start our proof. Statements, reasons. Number 1, angle 4 is congruent to angle 8. Well, that is given. Number 2, well, if we know 4 and 8 are congruent, and then we also know 4 and 8 are what we call corresponding angles, that means we can automatically say line L is parallel to line M. Why? Because we just saw the converse of the corresponding angles postulate, which states if you have two corresponding angles that are congruent with a transversal, then you're going to have two parallel lines. Let's look at the next proof. In the next proof, we have been given some information about the measures of angles. So I'm going to go ahead and set this up. We have statements here, reasons here. Number 1, I'm told that the measure of angle 2 is going to be 10x plus 8 degrees. I'm told that the measure of angle 3 is going to be 25x minus 3 degrees. And I'm also told that x is 5. That's given. What am I going to do with this information? Well, I can substitute x is 5 into those. So I can get the measure of angle 2 is going to equal 10 times 5 plus 8 degrees. The measure of angle 3 is going to be 25 times 5 minus 3 degrees. What did I do? I used the substitution property. Number 3, if you're looking at this information here then, you should recognize that you're going to have two angles that are going to be simplified, or you need to simplify here. So we got measure of angle 2 is going to equal 58 degrees when we do 10 times 5, and then we add 8, and then when we do 25 times 5, and we subtract 3, we're going to get that the measure of angle 3 is going to be 122 degrees. What did we do? We simplified. Now if you notice these two angles, if we added them together, they would be equal to 180. So if I said that the measure of angle 2 plus the measure of angle 3 is equal to 180, what did I do? I added them together. That would make this the addition property. I'm going to kind of skip down here on number 5. If I know I have two angles that add together to be 180, what's that tell me? That the two angles are supplementary. So angle 2 and angle 3 are supplementary angles. That's number 5. Why? Well, the definition of a supplementary angle tells me that if two angles have a sum of 180 degrees, then they are supplementary. And then I'm going to pull my number 6 up here because I ran out of room. Number 6. If 2 and 3 are supplementary, and look at where they are in position to these lines, where we have a transversal and two other lines that are cut by it, then what we can say is that R, line R, is parallel to line S. Why? Well, we just learned the converse of same side interior angles theorem, which states that if you have two same side interior angles that are supplementary, then the lines are parallel.